Hello and welcome to Silax. Our guest today is Dr. Thorben Hülsdünker, who is a researcher at LUNEX University. Thorben works on stroboscopic training and visuomotor performance in top-level athletes. He told us about the importance of brain and sport in particular, and improving perceptual, cognitive and motor functions of top-level athletes. We also had a chance to invite you to an event we will both participate in. Our guest today is Dr. Thorben Hülsdünker from LUNEX University. Thank you for coming.
Thanks for having me, Hannah. It's a pleasure being part of your podcast.
Thank you. Nice to hear that. So normally we always move on to the research, but first I actually have to ask you about your university because I'm not sure that everybody in Luxembourg knows about it. So what is LUNEX University?
LUNEX University is quite a new university. So we had the first students starting in 2016. So currently we have 6 degrees overall, 3 bachelor degrees and 3 master degrees. These degrees are in the field of physiotherapy, sport and exercise science, and international sport management. We have around 700 students at the moment from more than 40 countries, so quite international. And in addition to the teaching, we also have different research fields that we are working on. And one of the research fields I'm leading, especially the one for neurophysiology and motor control. So everything that works on the interrelation between the brain and the body.
Okay, so you now already explained a little bit what you're working on, but could you tell us a bit more in detail? What do you focus on in your research at the university?
Basically, I'm focusing, as I said, on the interrelation between the brain and the body. So initially, I was studying a bachelor and a master in sport and exercise science. But very early, I was always interested in how the brain contributes to sport performance. So while doing my PhD, I decided to study a second master degree in experimental and clinical neuroscience. And that brought me to this field of sport neuroscience, let's say, so how the brain determines performance. And that is what I'm currently working on at the moment. So we are investigating, for example, athletes and non-athletes. We compare their brain activity, what are the differences in their brain function, and how this is related to their performance.
And as you mentioned performance a little bit and athletes and all that, I know you prepared also a pub quiz question for our listeners. So let's start with that before we continue discussing your research. Can you ask the question?
Of course, we want to bring our brain always to the best possible state, let's say. So here's my question. So when we talk about athletes, what is a brain activation technique that is actually used for improving sport performance? So option 1, athletes are licking on a 9-volt battery to electrify the brain. Option 2, the athletes wear antenna to collect some stimulating cosmic radiation. Option 3, the athletes make a handstand prior to a competition to increase the blood flow to the brain. Or option number 4, the athletes watch videos of fast animals to transfer their skills to their own performance.
Okay, great question, and already got me thinking. I honestly hope it's not the handstands because I'm very bad at it. So if I wanted to improve my performance, I would probably not be able to. But that's just my personal view on this. But coming back to your studies and your field of research and all that, I was always wondering, in order to do sports science and research athletes, do you have to be a sport person yourself or not?
At least I think you should be interested in sports. So for me, I'm not a professional athlete. So I was always interested in sport. I was always doing sport, but not, let's say, on an international level. I was more focusing, let's say, what are the performance determinants, especially in the brain, that allows an athlete to reach the highest level. So I'm not a professional athlete, but to work in the field of exercise and sports science, I think you should have at least some interest for sport, let's say.
Of course. I mean, it would be very strange if you just really couldn't care less, because it is a very big part of your research, right? But coming back to the brain, why brain? Why did you get so interested in that? Did you find out something yourself? You figured it yourself, or how did it end up as a mix? Or was it just completely, accidentally, okay, let's do that?
Yeah, so basically, I was always interested in sport and especially sport performance. So, what is the difference between an athlete and a non athlete? So, what allows an elite athlete to perform on such a high level when compared to a non athlete? And of course, there are many reasons for that, and there are many established fields. So, if we talk about, for example, strength or endurance or coordination or something like that. But at that time, when I started studying, there was not that much about the brain, actually. And I was always asking myself, okay, why is no one investigating the brain, at least not systematically? Because if we talk about the brain, this is the most complex organ that we have. So it's just some kind of a supercomputer, let's say. I just found a study just estimating the computational power of the brain, and that was quantified with around, if I remember correctly, 12.5 million terabyte of storage capacity, which is quite a lot. So I was wondering, why is nobody investigating the brain? And then already very early in my studies, I started to try to figure out what the interrelation is between brain and performance. So how does the brain contribute to the performance? And that is basically what I'm still working on.
When it comes to the necessity, actually, why do top athletes need to improve that? Is it something actually that's gonna really make them win? Is it this small margin that is going to let them be first or second? This better perception, better cognitive abilities, motor functions, or maybe it's just the way they dress. Where are we looking for the best margins right now?
So the brain is definitely one of the most important performance determinants. So if we think about sports, and that basically applies to every athlete, if you want to interact with your environment, generally speaking, what you need is perception, cognition, and motor control. So you have to perceive your environment, especially with the visual system, which is the dominating sense for us, for humans. Okay, so you have to perceive visual information. You have to process these information and, for example, make a decision of what should be your next task, let's say. And you have to perform movements on a very high level. So motor control also plays a very important role. And all these processes are in the brain, basically. So the brain determines the quality and also the speed of these processes. And if you think about sports just like table tennis or badminton or tennis, soccer, and many different other sports, you have to make decisions, you have to perceive under critical time pressure. So the faster your brain works and the higher the quality of your perception, of your cognition, and of your motor control is, the better will be your performance. And we can also see this if we compare athletes and non-athletes, that the brain of athletes is just working faster, is working at a higher level. So there are definitely adaptations in the brain of elite athletes that allow them to perform on a higher level.
Okay, so now it's going to be the chicken and egg question, actually. You said that brain is key, right? And you can notice that in top athletes, it is just performing better. So can we already establish that it's because they were born like this? Or is it that they just done the right training to develop it this way?
No, we can definitely say that training at least plays a role. Okay, so of course, there could be the option that some athletes are born as athletes, let's say. So there's some kind of genetic predisposition that allows them to react faster or to make better decisions. Nonetheless, training definitely has an influence. So there are many training studies where you're doing training, for example, for visual processes or cognitive or motor processes, and you see that you can still improve your performance. So you can actively train the brain that will allow you to perform at a higher level.
Okay, and your research when it comes to training the brain, what do you do? How can we help our brain? Let's say we as top athletes, but we also as normal people, but I guess starting with top athletes. What are you suggesting to do? What are you checking? What are the results?
What we are working on is especially the visual system. So I said that the visual system is the dominating sensory system that we have. So more than 80% of the sensory information is actually visual information that we process in our brain. And we have seen that especially for high-speed sports, just like badminton or table tennis, the visual system is performance determining. In other words, the faster your visual system in the brain works, the faster you can react. And the faster you can react on the court, the better you will perform, basically. So our research in terms of training focused on the visual system and to find out how we can specifically address the visual system in the brain. And to do this, we have especially focused on so-called stroboscopic eyewear that should address visual processes and make the brain and make the visual system faster.
And this means eventually the so-called stroboscopic glasses or shutter glasses, I think you can call them as well, right?
Yes, right. That is the technology that we are using. So the shutter glasses are changing between clear and opaque states. Okay, so you're wearing these glasses during your normal training, basically your normal training drills, and you just have these shutter effects. It looks a bit like a stroboscopic effect. So you cannot see, for example, the whole trajectory of the ball. You just see single snapshots of the ball. In other words, you reduce the amount of visual information that is transferred to the brain. And by doing this, you train the brain to process the information that is still available faster. Because you have a training stimulus, the brain will adapt. And after the training, and that is what we have seen in the study, the perception is just faster than before. So the brain has learned to perceive a certain stimulus with less information. And that will then help you on the court when you will perform in normal visual conditions. So in a competition when you are not wearing the shutter glasses.
So I've seen some videos with you demonstrating how it works. And first question I actually had is, don't the athletes actually feel bad afterwards? I mean, because, for me, stroboscopic light is something that I think of, I don't know, discos and whatever. And after a while, when it kind of does this changes of light and opaqueness and whatever, I don't feel great. That's not a problem if they are working with these glasses.
It can become a problem if you're doing this for very long periods. So when we train with the athletes, we have shorter intervals. So they are training with the glasses, for example, for a minute or 1.5 minutes. And then they have a break because otherwise, if you're wearing the glasses for 10 minutes or so, then at a certain point, you're getting very fatigued, especially mentally fatigued, and also probably dizzy.
Yeah, exactly. That's what I was wondering, because that's one of the facts you did not mention. You only rather talked about the span needed so that you can notice effects of this training, right? And we were talking about 5 weeks that you were researching. After 5 weeks, you could notice some differences.
Yes, so we did 2 studies, one study with 4 weeks and one bigger study with 10 weeks. And in both cases, we were able to see improvements in the reaction time. Okay, so after the training with the stroboscopic eyewear, the athletes were faster. And in the second study, in the 10-week study, we also investigated the brain. So we were interested in the speed of the visual system. How long does it take to perceive a stimulus? And there we have seen that the visual system also got faster after the training. And what is maybe most important is that the fact that the athletes got faster in the brain directly transferred to the reaction speed. So the reason why they got faster in their reaction is because their brain was working faster.
Okay, and when you've done this study, how do you actually measure the reaction time? How do you know that it's improved?
In these studies, we're typically doing this with a very simple paradigm. So we have a response pad, basically. So the participants are sitting in front of a computer screen, because if you want to measure the brain activity, you cannot do this on a court. If you would do this on a court, there are too many artifacts. You won't be able to identify any brain activity. So we have a very standardized setting. The participants are sitting in front of a computer screen. We are stimulating their visual system. So we have very specific stimuli that activate only specific parts of the visual system, because you have to take in mind that we have more than 30 different areas for the visual system, and we only want to attract one. So we are presenting a very specific stimulus. And the task of the athletes is then just to press a button as fast as possible whenever they see on the screen a motion of the stimulus. Okay, so there is more or less a stationary image, and this image starts moving at a certain moment in time that the participants cannot anticipate. And when they perceive the motion, then they have to press the button as fast as possible. So very simple, a very standardized paradigm.
And they do that while sitting?
Yes, they are doing this while sitting.
What kind of an image is that?
Basically, these are circles in different gray shadings, let's say. So it is a stimulus that has a low luminance, a low contrast, that specifically activates certain receptors that we have in our retina and specific areas of the brain, and specifically the area that is responsible for motion perception. Because if we talk about sports, we are interested in motion. We have to perceive the speed, the trajectory, probably the spin of the ball, while something or some information like color are less relevant. So we are using a specific stimulus that selectively activates the visual motion system. And these are basically circles that either expand or contract. And this activates the visual system, especially in the motion area.
Sounds really interesting, although I don't know, maybe a good change from the usual running and doing other things as a typical exercise. And I'm sure that nowadays we just don't realize even how much there is done behind the scenes for all the sports science, and how much top athletes are actually helped with all these types of exercises. So good to hear that. But I've also seen on one of the videos that you're also using these kind of pads with lights. Is that also to measure the reaction time, or what do you use it for?
What do you mean pads with lights?
So these are kind of like rounded things that you attach to, I don't know, to the wall or wherever, and there is light and you have to react to it. That's what I meant.
Okay, so the lightning pods.
Yes. Okay, these are pots. Okay, for me these are pads, but yeah, this is the same idea.
Okay, I see.
Do you use this also to develop the reaction time and for top athletes, or is it some other research that you're doing?
Yeah, the principle is basically the same. So these lightning pods or pads you can basically use for both, for assessment and for training. So with these pods, you have a bit more flexibility. So you can attach these to the wall at different positions. You have a bit more dynamic situations, let's say. So when compared to the very standardized settings in the lab, where you just have to press a button, let's say with your index finger of the dominant hand, with these lightning pods, you have some more flexibility. You can make it a bit more specific to the sport. So these are used in more sport-specific training and assessment.
Just because our listeners are probably wondering what we're talking about, and we're talking about motion and color and changes and all that, I'm definitely going to share some videos of what I've noticed and I've seen in the show notes as usual in the podcast. So in case you're wondering, you go there and you will be able to see something. But coming back to your research, you mentioned that you don't only focus on athletes. So if you don't, what kind of research do you do then for non-athletes?
Basically, the non-athletes are always our control groups, let's say. So we are interested in the mechanisms in the brain of athletes. So what makes them better, let's say, when compared to the non-athletes. So to figure that out, we have to compare these two groups. So we have a group of non-athletes who are, for example, not playing badminton or not playing table tennis, and we are comparing them to a group of athletes. And then we are checking, okay, what is different in their brain? What is different, for example, in their reaction time? And this is another reason why we are not, for example, doing the experiments at a table tennis plate or on a badminton court, because in that case, the athlete could have an advantage because they are familiar with the setting. Okay, so this could be the reason why they are better, because they are performing in this environment for many, many years. However, we see that also at very simple tasks, in this computer-based task that I've just mentioned, with these motion stimulus, with the circles, they are moving, and you just have to press a button. This has nothing to do with badminton or with table tennis. But still, the athletes are reacting faster, and still the brain of the athletes also perceives the stimulus faster. And that is basically the idea why we include the non-athletes, just to figure out what in the brain adapts in the athletes.
And is it possible to say that in the group of non-athletes, you would have people who just do sports, as for pleasure, and those ones that don't do any sport, and there will be differences between these groups too, or not?
Yes, there are differences as well. Okay, so we have seen, for example, that some non-athletes or participants in the non-athlete group, they were not playing badminton or table tennis, but some were doing, for example, martial arts or something like that. Okay, so also a sport where you have to react very quickly, not on a professional level, but more or less just for fun. But also for these persons, we see that their reaction speed was faster when compared to other non-athletes who were actually doing no specific sport.
So you notice that too. That's good, because I assume that the control group is just mixed of both groups and you don't necessarily research that. But okay, so I'm not a professional athlete, but still you got me interested. How much can you actually stretch the reaction time? What kind of differences are we talking about before the stroboscopic training and after?
For the elite athletes, we talk about around 12 to 13 milliseconds. So after the training, you are 13 milliseconds faster in your reaction speed. I know that does not sound that much. However, you have to imagine that, for example, in badminton, you have ball velocities up to 500 kilometers per hour. So that is at the moment the world record, I think 497 or something like that. But even the irregular smash in badminton, let's say, is around 250 to 300 kilometers per hour. And with that speed, 30 milliseconds are already quite a lot. So we have calculated that, and the distance that you gain, let's say, is around 20 to 30 centimeters. Okay, so after the training, you are able to perceive the ball 20 to 30 centimeters earlier in the trajectory, which means that you have this additional time to prepare your movement and execute your movement. And the more time you have, the better the quality of this movement will be. And this is how the faster reaction improves your performance.
Absolutely. I can even testify myself. I'm a volleyball player and beach volleyball player. And if I have more time, I'm definitely well prepared. And, I can just do the right, I don't know, knee bend and everything else. So everything works better. But when you just mentioned that stretching, does it stay? So is it like you do the training for, let's say, 10 weeks, the longer one, and then you're just faster, or it actually wears off?
Yes, we have investigated that. So we had the participants training for 10 weeks. Then we investigated their reaction time and we found the 30 milliseconds. And then we let them continue with their regular training, so without the stroboscopic eyewear, and tested them 6 weeks after. So they were training for 6 weeks, normal training without stroboscopic. And they were still faster than prior to the training. Not as fast as directly after the training, but still faster when compared to prior to the training, which means that the positive effects on the reaction time seem to not only be short term, but at least can be maintained, let's say, for a period of 6 weeks.
Okay, but you don't know longer, obviously. That's for the next research, next program for you, I guess. When it comes to the sports, because you mentioned badminton and ping pong, have you noticed differences there? I guess, from my lay person perspective, it's faster for ping pong than for badminton, or not really?
The sport is faster, actually. So, of course, the higher ball velocity we have in badminton. However, the distance between the players is also larger. So, table tennis is a bit faster in terms of reaction time. And yes, there are differences. So we have two groups of badminton and table tennis athletes. And when you compare these two groups, you also see differences in the reaction time. So the table tennis players are around 10 milliseconds faster. However, we have to consider that the group of table tennis athletes also had more training time. Okay, so the two groups are not perfectly comparable because the table tennis group had more experience and more training load. So it could be just the result of training and not the sport in general.
So just to sum up, we just need more research to know for sure in this particular situation. And talking of more research, so what's next? You focused more, let's say, on the visual part, and I understood that now it's more about the listening part, the auditory part? Is that what you're going to focus on right now in the latest research?
Yes, that is one of the areas. So, as you said in the beginning or the last years, we were especially focusing on the visual system, because the visual system, as I said, is a dominating source of sensory information. So we try to improve the visual system. However, if we think about sports like badminton or table tennis, it is not only the visual information that may be important, but also auditory cues. Okay, so with every ball racket contact, doesn't matter if we have badminton or table tennis, we also got a sound that provides information, for example, of the type of the shot. And this is what we have investigated in a recent study. So we have just recorded realistic visual and auditory information during a real badminton task, basically. So the participants were performing on the court regular smashes, regular drops, and we were measuring their speed of the shot and the auditory information. And we're then presenting this in a lab experiment, so the visual and the auditory information. And we compare their reaction time to the visual, to the auditory, and when combining both. And what we observed is that when you combine both auditory and visual information, then you react fastest.
So this is obviously very, very important. I'm again trying to think about the sports I do, and I would never really analyze it from that perspective, that the sound of the ball being hit also gives me some cues, but it's good to look at it from this perspective. But you said that is one of the parts that you've been researching recently. So what is next? What are the other projects that you're going to work on?
Yes, so another important project is the integration of visual, of cognitive, and of motor components. Okay, I said in the very beginning, the brain controls everything related to perception, to cognition, and to motor control. And for us, and also for elite athletes, to communicate and to interact with the environment, all these three parts always come together. Okay, so when you want to defend a smash in badminton, you need perception, you need cognition, and you need motor control. So one of the big projects that we are currently working on is to train this in an integrated way. So not isolated, visual or cognitive or motor, but together. And this is something that we call VCO-motor training, so visual, cognitive, and motor training. And for that, we are currently using a new technology that is called SkillCourt. And this SkillCourt technology was released some years ago and was specifically designed to integrate all these different parts. So every task that you have to do has a visual component, a cognitive, and a motor component. And the idea is that by training all these three parts together, that we have a better transfer from the training to the on-court performance.
Which sports are we talking about in this case?
That basically applies to every sport. At the moment, we are working on a project together with Frankfurt in Germany for soccer players. But we are at the moment still in the process of validating the technology. So the technology is quite new. It was released some years ago. And first we have to figure out if the quality of the technology is sufficient. So if we really measure with the technology what we want to measure and if we can trust the results. So at the moment we are doing quality checks with the technology, which are quite promising, or the results not published yet. However, studies are finished and the results are quite promising. And in parallel, we are already starting with some training studies. And as I said, at the moment, there is one study running in Frankfurt, and we will start with another study hopefully soon at LUNEX University. But what sport it will be, it's not defined at the moment.
It's definitely broader in this case, right? So as you said, you can apply to many. But actually, you got me inspired for another question. So how does such a cooperation look? In the sense of, okay, you have a technology, you want to research, you want to check, and how do you find the athletes that you can work with in such a particular project?
Typically, we contact the clubs, for example. So over the last years, we have established quite a broad network. So we were in contact, for example, with the German Badminton Federation, and we did many projects with them together over the last, I think, around 7 or 8 years. We had collaborations with the Luxembourgish Table Tennis Federation, the European Table Tennis Union, the International Table Tennis Federation. So these are contacts, let's say, and we are asking them if they are interested in supporting these studies. And over the last years, we were lucky, let's say, that they were interested in the projects and the projects of how the brain determines performance. And this is typically how we get the participants. We are getting in contact with the clubs, promote, let's say, the project, and then hope that they like to participate.
Well, let's hope for next time and next projects. Thank you for explaining all this to us. And unfortunately, we're slowly coming to an end of our episode. So first of all, before we just wrap it up, I would really like you to repeat the question that we asked at the beginning of the podcast and then tell us what the answer is.
In the beginning, I asked what brain activation technique is used by athletes to improve the sport performance. And the possible answers were licking on a 9-volt battery, wearing antenna to collect stimulating cosmic radiation, make a handstand before a competition to increase the blood flow to the brain, or watch videos of fast animals to transfer their skills to your own performance. And the correct answer here would be the first one, so licking on a 9-volt battery. There is a famous German sprinter, Gina Lückenkämper, and she did this actually. There are many also newspaper articles about that. So licking on a 9-volt battery, let's say, to electrify the brain, to bring the brain in a higher excitability level, let's say, that should then improve performance, for example, for the sprint start. That you are on a higher attention level, you are better in reacting, and then also getting a better time, for example, for a 100-meter sprint.
And you, as a researcher and scientist, confirm that it really works?
To be honest, I'm not aware of any study that has investigated the effect of licking on a 9-volt battery on any kind of performance. So at the moment, there is no, at least from my point of view, no scientific support for that. Although the idea is maybe not completely wrong, because in the end, everything in the brain works with electricity. So also if you want to induce adaptations in the brain, you need electricity. Okay, so the same as you can train the muscle, you can also train the brain. And in the brain, everything works with electricity. And there are actually studies at the moment that try to specifically stimulate certain parts of the brain with electrical current to boost, let's say, training processes. So if you want to train, for example, the visual system, it could be in the future an option to stimulate the visual area with some small currents, of course, to just facilitate these adaptation processes. So licking on a 9-volt battery, from a scientific point of view, I would not say that there is too much support that it works. Probably it could also be a placebo effect. But the idea of using currents to improve performance is maybe something that could be interesting for the future.
Yeah, I've never seen her do that, but I was just wondering also like how long this effect lasts, because I don't know, how does it work? She holds it, licks, and then starts running. I mean, she probably has to do it before she is ready to run. So yeah, I also was wondering like how much time do you actually, the time frame for the starts, right? I guess you don't know when she does it.
I think that would be in the call room or something like that, but not on the track. So not immediately
Exactly.
prior to the start. There is not a 9-volt battery just next to the starting block. So that is not the case. But yeah, prior to the start, and then, as you said, the question would be how long would this effect last? But again, maybe one additional information, if you come back to the brain stimulation with current, if you're doing this, if you're stimulating the brain with small currents, this is an effect that can last up to 1 hour. So it is not something that fades away after a few minutes or a few seconds, but this can be a longer lasting effect.
And do you know if it's painful?
No, it's not. It's not.
Okay.
So when you're applying the current, when you ramp up the current intensity, you will feel this. However, if then the current is stationary, let's say in intensity, then there is no no feeling or no pain, even not discomfort associated with that.
Okay, so way better than using, I don't know if you know this device, the Compex for physiotherapy and whatever. That kind of like, if you really want to train well, it's not very enjoyable, the kind of stimuli you get.
No, so this should not be the case for for the current stimulation for the brain. If you're doing this in a way that it is hurtful, then maybe the current is too high. You did something wrong.
Okay, good to know. So this is a science podcast. So if any one of you listeners hears of any study that we are not aware of, please let us know. We're always interested in different things that people are doing. And the only thing that remains right now, unfortunately, is just to thank you for your participation today and all the explanations. And as I said, you can check in our show notes all the different things that Thorben is doing. And also I have some good news for you guys. Very soon, more or less, because in November, we will both be there at the Researchers' Days. So this is this event organized by FNR, so Fonds National de la Recherche, on the 25th and 26th of November. I will still tell you a little bit about it. I'm sure I'll have enough time to repeat it many times. And it's an event where you can go and participate in science cafes and also scientific workshops. And I think, Thorben, you're going to have a workshop for the participants.
Yes, I have a workshop as well, and this workshop is also focusing on my field of research. So what I have now explained with the visual system and how we can test the visual system, how we can train the visual system, that will be the content of the workshop. So also stroboscopic eyewear will be there. So if you want to train as the badminton players did in our study, you have the chance at the workshop as well.
So I think you've just convinced everybody. So once again, 25th, 26th of November in Rock Hall in Esch. I didn't mention where, and I'll be informing about this still a couple of times. Thank you very much for today. Thank you. Our guest was Dr. Thorben Hülsdünker.
Thank you, Hannah.
And this is it for today. Thank you very much for listening. I hope you enjoyed the episode and the discussion we had with Thorben. Please, as usual, don't forget to subscribe, to follow us, to check us on Twitter, LinkedIn and Facebook. We're always happy to hear your opinions, comments and discuss different topics related to research in Luxembourg. This was SciLux and my name is Hanna Siemaszko.